Hello and welcome to another pre-calculus lesson. Today we're looking at the cosine law. So we're finished up with the sine law, and we're going to look at cases of triangles where the sine law doesn't have the ability to help us solve the entire triangle and where we actually require the use of a different law. So the things we're going to focus on: sketching a diagram and solving a problem. This is kind of key. I have basically never solved a sine law or cosine law problem without sketching a diagram of the triangle. Just for me, it just doesn't work until I see it. I don't know which law to use until I can see every angle that I'm given and every angle that I need to find. So sketching a diagram, in my opinion, this is one of the most important things you can do when working on cosine and sine law. Recognizing when to use the cosine law, this will be a simple rule, and then explaining the steps in the given proof. We'll go through a quick proof of the cosine law. Here is an exploration. This is where a lot of you'll have some kind of aha moments where things will make most sense to you if you discover these things on your own without a teacher standing there explaining them. If you just work through this exploration on your own, I think it'll be a lot more meaningful to you than actually watching me go through this. So I do expect you to finish this. This is probably the most important thing for you to do in this lesson, and the lesson that I actually teach is only kind of secondary to that. So that said, stop the video to complete that other part that's in your handout, and then when you're ready you can move on to this part and we will look at the proof of the cosine law and go on and use it to solve problems. So when we're trying to solve any triangle, including non-right triangles, given all three sides, so this is the side case, or two sides and an included angle. Now you notice how this is different from when we use the sine law. We used the sine law when we were given angle side, so that angle wasn't included. This is now side angle side, so two sides sandwiching a known angle. That's when we can use the law of cosines. If you're ever in doubt, just try one, and if it doesn't work, if you find you don't have what you need, try the other one. So here, given triangle ABC with respect to the opposite sides a, little b, little c, so the angle, given a capital letter, is always opposite its sort of respective side, given the little one, the lowercase letter. Wow. So here's how the proof goes. Draw an altitude from vertex A. Now an altitude, this is basically just a height line. Okay, it's the shortest distance that will go from vertex A down to side A here, or length CB if you choose to look at it that way. So I'm just going to draw an altitude, and this software allows me to draw it perfectly straight, which may not be the case for you drawing at home, but give it a try, do your best, and label it H, which we will do right here. Forming two right triangles, we can now use Pythagorean theorem and the cosine primary trig ratio. So this is one of our right triangles, which will now be triangle AC, and then this 90-degree angle, which we haven't given a letter. And this is a right triangle as well, which is the triangle that goes from A around to B and back to A. So forming two right triangles, let's see what we have here in triangle ABM. So I guess we call this new point M. Oh yeah, that instruction was right here. Way to follow your own instructions, doll. Classic. Okay. In triangle ABM, let's solve for this height, H. Okay, now if we want this height, we can use angle C, because it's the only angle whose value we actually know here because we don't know this angle, because this h, this altitude, it does not cut A in half. Clearly this angle is different from this angle. Okay, so h does not cut A in half, so we don't know what the value of this angle is, and we don't know what the value of this angle is, because they're different. So in this triangle ACM, the only angle we know is C. So let's work with C and use our primary cos ratio to figure out what's going on. So we're looking at triangle ACM, which is this one right here. Now I've gone ahead and made a few definitions. So we call this length, CM, this unknown length x, which leaves this unknown length BM as A minus x, because the entire length was A. So if we subtract this length from the entire length, we're left with this one. So that's why this is A minus x, because it's the whole thing except for this part we've called x. So triangle ACM. Now first let's relate B, x, and h. So we can do those using Pythagorean theorem now. B squared is the hypotenuse, so B squared equals the two legs squared and their sum. And then this angle C, like I said, is the only one we know, so let's work with it. So we go cosine of angle C equals adjacent, which is x, divided by hypotenuse, which is B. Alright, now we have everything we need. So let's rewrite this as B cos C equals x. Now in the other triangle, ABM, we have the relation of these ones, A minus x, and C and h. So in this case, C squared equals A minus x all squared plus h squared. Alright, and then the cosine of angle B is adjacent A minus x over hypotenuse, which is C. So cos B equals A minus x over C. Alright. Now, h squared we can rewrite in terms of these known entities over here. So h squared is b squared minus x squared. So then we can write c squared equals a minus x all squared plus b squared minus x squared. Now expand this and start simplifying. C squared equals a squared minus 2ax plus x squared plus b squared minus x squared. And here's where you notice that the x squareds are going to disappear. So we have plus x squared minus x squared, and they're gone. So now we're looking at c squared equals a squared minus 2a times x, which I'm going to leave like that, plus b squared. And x, of course, we can rewrite in terms of this. So b cos c, x is equal to b cos c. So then we write b cos c right there. And then we have plus b squared. So here is basically your cosine law. And all you need to do is solve for whatever it is you're trying to solve for. So c squared equals a squared plus b squared minus 2ab cos c, which is just a rearrangement of this exact thing. I've just taken and I've changed the order, and this is your cosine law. Okay, so moving on. In summary, the cosine law for any triangle ABC, and we know how to label those, so just make sure you're always putting little side A opposite side or angle A, and little side B opposite by side angle B, wow, and so forth. The cosine law states that a squared equals b squared plus c squared minus 2bc cos A. So it's always whatever you have alone on this side, that's the angle you're taking, and everything else is the other two sides. And of course, b squared equals a squared plus c squared minus 2ac cos B. And finally, c squared equals a squared plus b squared minus 2ab cos C. And of course, any one of these can be solved for the angle. So just isolate cos of the angle, and then when you get to the very end, take the inverse cos to isolate the angle itself and end up with an angle in degrees. So let's get a little practice here. In triangle ABC, A equals 11, B equals 5, and angle C equals 20 degrees. Sketch a diagram and determine if the length of the unknown side in the measures of all the unknown angles to the nearest tenth. So let's sketch a quick diagram here. We know, let's just make a triangle. Let's go A and B and C, and as it happens, C looks very near to 20 degrees. So side A will be 11, and side B, of course across from B, will be 5. So these are the things we know, and this is a side angle side triangle, and we know side angle side requires the use of the cosine law. So let's go ahead and get started. We know that we have A, we have B, we have angle C. So we want to solve for side C. Let's go c squared equals a squared plus b squared minus 2ab cos C, which of course is cos 20. Oh, sorry, I should put C in there and then we'll substitute the values in the next time around. So cos C. So c squared equals 11 squared plus 5 squared minus 2 times 11 times 5 cos 20. Now be careful with your order of operations here, because I've seen a lot of mistakes where the equation is set up perfectly and then the order of operations totally ruins you. This subtraction of 2 times 11 times 5 cannot happen because it is multiplied by cos 20. So you do cos 20 and then you multiply all these things, and only after you've done this chunk, because of bed mass, multiplication comes before subtraction, only after you do this chunk can you do that subtraction. So here we go, c squared equals 11 squared is 121, plus 5 squared is 25, minus 2 times 11 times 5. 11 times 5 is 55, times 2 is 110, cos 20, and that is something I will not be able to do in my head, so I'm going to have to go use a Google calculator. So cos 20, oh, better do it again because I think that's in radians. There we go, cos 20.93969. Now we're going to multiply that by 110, and that would give us 103.366. So this is 103.3662 for good measure. 121 plus 25 would give us 146, and that is c squared equals the difference between those two. So calculate the difference. 146. Now, of course, I'm doing it backwards, so I'm going to get a negative answer, but in fact, the answer is positive because the 146 comes first in our equation. So 42.63. So c squared equals 42.63. And then we're going to take the root of that, but I have to make it positive first. Now we're going to take the root of that answer. And we get C, which is 6.53. C equals 6.53. So now that we have the value of C, we can use that to draw a more accurate version of our triangle and figure out what we have going on for angles A and B, which we're going to solve for in a minute. Whoa. Okay. So we know our longest side is side A, which is 11. And this would be angle A then. And clearly, if these sides are as short as 6.53 and 5, and this is angle B, and this is somewhere that's supposed to be 20 degrees, this more accurately represents our triangle here. And you can see here that angle A is obtuse and angle B is acute. So I would recommend dealing with your acute angles first, and we can use the sine law to solve for this acute angle B, and then we can just use our 180 sum rule to find angle A. So we say sine of 20 degrees, which is angle C, over side C, which is 6.53, is equal to sine of angle B, which is what we're trying to solve for, that acute angle, over side B, which is 5. So multiply both sides by 5 and we get 5 sine 20 degrees over 6.53 equals sine B. Of course, we're not trying to solve for sine B, we're trying to solve for B. So take the inverse sine of both sides, sine minus 1, 5 sine 20 divided by 6.53 equals B. And this is what we have to do to find B. So let's go ahead and do that now. 5 sine 20 over 6.53. So we go 5 sine 20 equals divided by 6.53. And then we take the inverse sine of that answer. And we get an angle of 15.2. So let's just round it off to one decimal place because the question asked us to do that. So we get 15.2 degrees for B. Now finally, A is really easy to solve. Angle A equals the sum of all the interior angles minus the two that we know, which are 20 degrees and 15.2 degrees. And you can go 180 minus 35.2. Of course, that'll give us 144.8. Now you could solve this in two other ways. You could use the sine law, which would only give you an acute angle, but then you could subtract that acute angle from 180 and you would find the actual value of A. Or you could use the cosine law and it will directly give the actual value of A. It won't give you an acute angle and then make you guess that it's obtuse and have to solve for it. So the cosine law is better for telling you when you have an obtuse angle. If you're not sure if it's acute or obtuse, use the cosine law. It's foolproof. Here's your turn, so you can go ahead and give it a try. Pause the video. When you come back, the answer will be here for you. So pause the video now. There's your answer. There's what your triangle looks like. I'm hopeful that you were able to come up with those. If you can't, go back and give it another try, and if you still can't, ask me about it in class tomorrow. We'll go over it together. So let's solve this one together. Triangle ABC, where A is 15, B is 12, and angle C is 32. So we'll try to make this reasonably accurate. So let's go an angle of 32. Okay. Now these sides are fairly close together, So this is angle C. Let's call this side 15. So it's a little bit longer. And this one is 12. It's a little bit shorter. And then we can do something like this. This is angle A, and this is angle B. And again here, it looks like angle A is going to be obtuse again. So that will sort of dictate what kind of laws we use to solve for these angles. So let's solve for side C here. C squared equals A squared plus B squared minus 2AB cos C, where C is 32 degrees. So let's go ahead and simplify this a little bit before we bother using our calculators. 225 plus 144 minus 15 times 12. 15 times 10 is 150, and then you add 30. So that will give you 180. Multiply that by 2, which would be 360. So 360 cos 32. 225 and 144 will give you 369. And this would be minus 360 cos 32. Now again, I can't caution you strongly enough. Do not carry out this subtraction. Your order of operations, multiplication comes first. So this must be done before this subtraction is done. So let's go ahead and do that. 360 cos 32. So we want to go 369 minus 360 times cos of 32. This calculator does order of operations for us, and we get an answer of 63.7, which is C squared. C squared equals 63.7, and of course C, you take the square root of that, and we get 7.98. So let's say 7.98. All right. And now that we have that, we can go ahead and solve for all of our other angles. So let's use the sine law here. So now we have C equals 7.98. So we can say sine 32 degrees, which is angle C, over side C, which is 7.98, equals sine of B. And the reason I'm doing B first again is that we know B based on our roughly to scale triangle. We know the B is acute and A is obtuse. So the sine law gives us acute angles, and it'll be easier if we do the one that we know is acute and then use our 180 rule for the interior angles of a triangle to solve for our remaining angle A. So sine B over 12. So that's that one there. So solve for this. 12 sine 32 divided by 7.98. So 12 times sine 32 equals, divided by 7.98 equals, and then we'll take the inverse sine of that to find our angle B, 52.83. So B equals 52.83 degrees. And then A is really simple to solve for. We go A equals 180 degrees minus angle C, 32, minus angle B, 52.83, and A, so we're subtracting 84.83, so this should leave us with 95.17, I believe. So let's go double check that. 180 minus 32 minus 52.83. $95.17. Okay, what do you know? Sometimes the brain actually works. So here's another triangle. You can go ahead and solve this. Hit pause now. I'll have the solution ready for when you come back. So there you go. There's the solution. First I found r, and then I used r in the sine law, and I was able to find p and q after that. We're going to call our quits for today, so I will see you in class tomorrow.